Okay, well, last time, lesson 24, we got a full taste of that Kirchhoff analysis. We used Kirchhoff voltage and Kirchhoff current laws together to analyze some semi-complex circuits. And we're going to analyze some more circuits, but before we do that, we have to learn another algebra trick, and that's how do you solve for two unknowns, x and y. Two equations, you can solve for two unknowns. If you want two unknowns, you need two clues, which means you need two equations. But if you have two equations, this is an equation with an x and a y in it. This is a different equation with an x and a y in it. Together, we can actually figure out what x and y equals. How do you do that? Well, it turns out this particular example 1 is ready to go. What we're going to do is we're going to add the two equations together. Can you do that? Sure. Imagine if I had a equals 5 and I had b equals 2. Would you believe me that a plus b is equal to 7? I've never had anyone challenge that. So yeah, you can add equations together. Add the stuff on the left, and if it's not like terms, then don't combine like terms. Add the stuff on the right. So on the left here, I'm going to go by like terms. I got a couple of x terms here. Those add up. 3x and 5x makes an 8x. And then here's why it's going to work so nice, why I said it was ready to go. If you look at the two y terms, one's a plus y and one's a minus y. When you add those up, there's no more y. It's gone. It's just gone. And then on the right side, you add the 11 and the 5 to get a 16. So look what happened there. I added these two equations together, and I got a new equation which doesn't have any y in it. It just has x in it. This one we can solve lickety-split. This is the old divide both sides by 8 trick to cancel the 8 off the x. And so I've got x equals 16 over 8 is 2. Boom! That was fun, huh? Now the thing is, you got to remember to also get y. So take your solution x equals 2, come up to one of these two equations, and it doesn't matter which one you use. It really doesn't. You can try it both ways if you like. It doesn't matter. I'm just going to grab the top equation for no particular reason. It says, now wait a second, it says 3x, but we know what x is. We just solved for it. X is 2. So it says 3x, and then it says plus y equals 11. Okay, cool. So I was able to take my answer, x equals 2, plug it in for x, and now look what I got. I got a 6 plus y equals 11. Do the old subtract 6 on both sides trick. Keep the sides separate, of course. Y equals 11, take away 6 is a 5. And so those are my two answers. X is 2, y is 5. Now if you want, you can, put them in a single box or something. But as long as you circle both of them, I'm happy. I can see that you have an x equal 2. I can see you have a y equals 5. Let's verify. Let's make sure this really is a solution. You're saying 3x plus y equals 11. That's the top equation. 3 times x is 2 plus y is 5. Does that really equal 11? And it does, because that's a 6 plus 5 equals 11. It works just great. Now the thing is, you have to check in the other equation too. So 5x minus y equals 5. Does it work here too? 5, we're saying x is equal to 2, minus y is 5. Does this equal to 5? And it does, because that's 5 times 2 is 10. 10, take away 5, it is indeed a 5. It worked! So the 2 and the 5 are the two values that solve both of these equations. All right, example 2. Here's another system of two equations. I got two equations. I want to solve for x and I want to solve for y. If you only had one of these equations, and I'm trying to block that one out, it's what I'm trying to do. If I only had one of these equations, you wouldn't be able to solve it, right? You couldn't tell me what the number for x and y is. You can't know one if you don't know the other. But when we have two equations together, we can solve them. So what do you got to do? Well, this one's not ready to add. Example 1 was ready to go, but this one's not ready to go. And don't write this down because it's not ready to go. 5x and 7x is 12x. If you add a negative 2y plus a 3y, you'll get a plus y. 33 plus 7 is 40. And I'm putting a frowny face because we didn't get rid of x and we didn't get rid of y either. We didn't get rid of anything. That doesn't do us any good. That doesn't do us any good. We need this kind of action. We need either the y's to go away when you add them, or it would be okay if the x's went away, but one of them, something. When you add the equations together, you want something to go away. So you have to sort of take a look at the x's and then take a look at the y's separately and say which one's going to be easier to make go away. So this is kind of like the common denominator game in a way. These are not denominators, but it's very similar to the common denominator game. You know, like, remember when you had to add like a half and a third, and you had to do the old, you know, I'm going to multiply this by 3 over 3, and I'm going to multiply this by 2 over 2. That way I have a 6 and a 6. I have the same thing, right? Common denominators. It's kind of like playing that same game. So you look at the 5 and the 7, and you say, well, I could think about making those both into 35s. The common denominator 5 and 7 is 35. Or if I look at the y's, I got a 2 and a 3. I can think about 6s. Common denominator, if you had halves and thirds, would be 6. Let's do that. So here's what you got to do. You got to take this minus 2y. You want it to be a minus 6y. So I'm going to take this first equation and I'm going to multiply it by 3. The second equation, in order to make that a 6y, I'm going to have to multiply it by 2. So you multiply the top equation by 3 and the bottom equation by 2. Now what's important here is you have to make sure you're multiplying all the way across. 3 times 5x is a 15x. 3 times negative 2y is a negative 6y. 3 times 7 is a 21. Make sure you're multiplying both sides of your equation by 3. Everything all the way across. On the bottom, what'd you do? We got 2 times 7x is 14x. 2 times 3y is a plus 6y. And 2 times 33 is a 66. And now we are ready to add, because look what we got going on here. The minus 6y and the plus 6y. If we add these two equations together, those are going to go poof. There won't be any more y terms. That's what we're looking for. So I add 15x and 14x makes it 29x. Over here, 66 plus 21 is 87. Okay. Huh. I didn't like that. Okay, so I need to solve for x, means the last thing I should do is there's my x. I need to cancel the 29, so I have to put 29 on both sides. And so x is what you get when you take 87, divide by button 29, and is that 3? Mr. Calculator, is that 3? That's exactly 3. Who'd have thunk it? X equals 3. That's nice. I wasn't expecting that. Anyway, we got x equals 3. Now the thing is, you got to remember, that's only one of your answers. You need x and y. So take any one of these equations. You could take this one, or this one, or this one, or this one. They're all good. They will all work just fine. I think I'll take the top one just because it's kind of my habit. It's no particular reason. I just do it. So if I substitute in x equals 3, what's this going to tell me? I have 5 times x, but wait, x is 3. Minus 2 times y equals a 7. Okay, so that's that equation right there. 5 times x, but x is 3. Minus 2y equals 7. Solve her up. 5 times 3 is 15. Minus 2y equals a 7. Got to do the old subtract 15 on both sides trick. Keep your sides separate, right? So the 15 minus the 15 goes away. I'm left with a negative 2y over here. 7 take away 15 is a negative 8. And lastly, looking at the y, you say, oh, I'm going to have to put a negative 2 underneath both sides here because I'm trying to cancel that off. So you have a negative 8 divided by a negative 2 is a positive 4. Gee, I really wasn't expecting that answer. So x equals 3 and y equals 4. Nice solution. And if you wanted to check it, you would have to check, remember to check in both equations. So maybe I'll do that real quick. Oops. Yeah, this is real quick. So I'm going to check here. I'm going to check the top equation first. 5 times x is 3 minus 2 times y is 4. Does that equal 7? That would be a 15 minus an 8. That equals 7. It works. Now, you have to check both. So I'm going to check the bottom. So it says 7 times but x is 3 plus 3 times y but y is 4. Does that equal 33? 7 times 3 is 21. 3 times 4 is 12. And if you add 21 plus 12, it works. You get 33. So we have the correct solutions. X is 3, y is 4. Okay, so keep your eye on the prize, right? What have we been doing here? We've been trying to add our two equations together and have something go away. We happen to make the y terms go away both times. We made this one into a minus 6 and a plus 6y. And so when I added those went away. You can get rid of the x terms. It doesn't matter, whichever is more convenient. But often the y terms are pretty convenient. Example 3. Ask yourself, what should we multiply these equations by so that we can set up for our addition method? Well, you've got two choices, basically. If you wanted to get rid of the x's, you'd have to take the 7 and the 12, and the common denominator would be 84. You'd have to turn them into 84s. Or, if you look at the y's, you get a 3y and a 4y, you'd have to turn them into 12s. And you just take your choice. Do I feel like making 84s or do I feel like making 12s? Usually the smaller number is going to be a little more fun. So let's make these into 12s. So what I'll do is, in order to make this 3y into a 12y, I will have to multiply the top equation by a 4. And in order to make this 4y into a 12y, I'll have to multiply the bottom equation by 3. Now we're not quite ready to do this multiplication yet. Keep in mind, you want coefficients equal and opposite, meaning opposite signs. In order for it to go the way, they have to be equal and opposite. Up here, the reason they went away is because one was a plus 6y, one was a minus 6y. Up here, the reason they went away is because one was a plus 1y, one was a minus 1y. You need to have them equal and opposite. So one of these should be a minus 12y, and it doesn't matter which one. I'll just kind of arbitrarily choose the bottom. I'm going to multiply the bottom equation by negative 3. So that's my plan of attack. What do you get? 4 times 12x is a 48x. 4 times a 3y makes a 12y. Equals, and remember, 4 times 4 is a 16 on that side. On the bottom, negative 3 times 7x is a negative 21x. Negative 3 times 4y is a negative 12y. Can you taste it? These are going to cancel when I add. I'm not done multiplying yet. Negative 3 times negative 2 is a positive 6 on the other side. Make sure you multiply all the way across. Our equations are ready to add. Add up your like terms. The x terms. 48 take away 21 is a, what is that, like a 27, I want to say? 28, yeah, 27. 27x. The y terms. Poof. And then on the other side, 16 plus 6 is a 22, actually. So looking at the x, you say, well, I'm going to have to shove a 27 underneath both sides, so it cancels off. X equals. And I suppose if you want to play with fractions, you can play with fractions and call that 22/27. But I think usually in a technical context, we have decimals. And my calculator is saying that is 0.814 with a bar over it. So if I wanted 3 sig figs, remember what the bar means. It means take the part with the bar over it and copy paste it forever and ever and ever. So if I wanted to round this to 3 decimal places, guess what? The 8's telling me to round this up to a 5. So x equals 0.815. That would be a nice 3 sig fig answer. What have I forgotten to do? I have forgotten to solve for the other variable. I got x, now I need y. Pick any one of these equations. This one, this one, this one, this one. It does not matter which one. They should all give you exactly the same answer. Try it if you don't believe me. But I want to solve for y, so again, I typically tend to grab the top equation, and unless it scares me and the bottom equation looks more fun or something, but I typically grab the top equation, plug into that one. So this top equation says 12x plus 3y. 12x is a 0.815, plus 3y is what we'd like to know, equals a 4. So I've plugged my x in. So now I got to get out this calculator thing, and I have to go 12 times 0.815, boom. 9.78 plus 3y is equal to 4. So that's what we're solving for. So that means I should subtract this 9.78 on each side of the equation. Try to make it look like a 9.78. So those cancel, of course. I've got a 3y here. 4, take away that, is a negative 5.78. Look at the y. It's got a 3 on it. We need to shove a 3 underneath both sides. That way it'll cancel off. Y equals a negative 1 point, like something. 5.78 divided by 3. Boom. It says negative 1.926 bar, which means negative 1.9266666666666, right? So if I don't put the bar, I'd have to put a million sixes. Now, if we wanted 3 sig figs, we would count the 1, the 9, and the 2, and we'd round here. Though I'm awfully tempted. If this is 3 decimal places, let's keep this one to 3 decimal places as well. See, that's the whole thing about sig figs. You keep changing your mind. So if I go to 3 decimal places, because that looks nicer, this 6 is telling me to round that up to a 7. Negative 1.927 is my y. Doesn't it seem a lot nicer if you've got 3 decimal places here than you've got 3 decimal places here? I think it looks nice. So there, I hope you're digging on this method. So again, the idea is you want to add the equations together, but you're not ready to do that unless something's going to go away. Either the x terms are going to go away or the y terms are going to go away. 2 more examples. What do you think of this one? Does that feel like a little bit of a ramping up? What color do I want? Let's do this green maybe. So I've got my 2 equations here. Look at these numbers. 6.3x, 1.2y, 8.4, 9.1x, 3.8, and negative 1.8. Well, this is why we have calculators. So how in the world are you going to figure out the common denominator, right? What's the common denominator between a 6.3 and a 9.1, or between a 1.2 and a 3.8? It's kind of hard to say. But you can always do this, right? You can always say, and let's make the x's go away just so I can prove that you can do it that way. I want to make the x's go away, right? I can take this equation, multiply it by a 9.1, and I can take this equation and multiply it by a 6.3. Now I don't even know what that comes out to when you multiply 9.1 times 6.3, but I know that it's the same when you multiply 6.3 times 9.1, so I know they're the same, so I know I'm making progress. So that's kind of your shortcut. So especially if you have weirdo decimal numbers, you might want to just do this. So I'm just taking, that's a 6.3, so I'm multiplying the bottom equation by that. That's a 9.1, so I'm multiplying the top equation by that. And it works pretty good. Now keep in mind, I need one of these things to be negative, and it doesn't particularly matter which one, so maybe I'll make the top one, I'll multiply by a negative. Because you have to have one of these come out to a negative and the other one come out to a positive in order for this to cancel. Okay, here we go. Now I'm going to get out my calculator and I have to multiply. What is a negative 9.1 times a 6.3? It is well, it's a negative 57.33x. Now I have to multiply the negative 9.1 times that, which is going to be negative. So this is 9.1 times 1.2 is, negative 10.92y equals. And then the negative 9.1 has to multiply that too, and it's going to be negative. Negative times positive is negative. So what do I got? 9.1 times 8.4, boom. I've got a 76.44, again negative. That's my new and improved top equation. Now my bottom equation, I guarantee this, right? But I'm just going to push buttons just to humor myself. 6.3 times 9.1 is indeed 57.33x, and it's positive. 6.3 times this, well, that's going to be positive too. 6.3 times, what the heck we got? 3.8 is, we've got a 23.94. And then over here, when you multiply the 6.3 times this negative number, you're going to get a negative. So what is it? 6.3 times 1.8, boom! It is an 11.34 negative. We have succeeded in making these equal and opposite coefficients. That means we're ready to add our equations together, and when you do, the x terms go poof. Looking at these y terms here, what are we going to have? We're going to have, well, you can either enter this as a negative 10.92 plus a 23.94, which will give you a, what'd you just do? Which will give you a 13.02 positive. Hey. 13.02y. Or you could enter the positive one first and take 23.94 and subtract 10.92. Either way, you're going to get 13.02y. And then over here, you're adding up two negatives. It's going to give you a bigger negative. Let's see, 76, 86, 87 point, looks like 78. And there we go. Almost done. Looking at the y term, we're going to have to shove a 13.02 underneath both sides to cancel that off. So y equals a negative. You take your 87.78 and you divide it by your 13.02 and you end up with a negative. Oh, if I go to like 3 decimal places, which sounds good, that would be 3 decimal places. I'm seeing a 7419, so the 9 makes that round up. There's a nice answer for y. Let me see if that's what I got before. Oh, that's the wrong problem. Huh. Looks like I didn't do it before. Okay. I'm going to hope I did that right. Now I'm going to have to solve for x. So come up to one of these equations. Typically, I just grab the one on top. Again, this doesn't matter which one you use. But you take your y equals negative 6.742 and you plug it into this equation. 6.3x, and we don't know what x is, plus 1.2y, and we do know what y is. Y is a negative 6.742, and that equals an 8.4. So we've got to finish solving this thing up. 6.3x. When you multiply these two things, you're going to get a negative something. 1.2 times 6.742. Boom. This is giving me an 8.0904. Notice I don't round off when I'm in the middle of a calculation. When I'm in the middle of a calculation, I like to carry all these juicy decimal places because I know that my answer will come out better if I do that. So I'm adding the 8.094 on both sides. I'll still have my 6.3x on the left. Those go away. And over here, 8.4, if you add that, you've got a 16.4904. Lastly, look at your x. It's got a 6.3 on it, so I have to shove a 6.3 underneath both sides. So x is, take your 16.4904, divide it by 6.3, you end up with a, and again, I'll go to 3 decimal places, 2.61, I'm looking at a 7.5, so that would round up to an 8. X equals 2.618. And so these two things together make up your 2-part answer. Okay, 2-part answer. One more. Ooh, not that one. One more. What do you think of that one? Now, at first glance, you're going to say, well, those equations are a mess. And you might even say, hey, none of these examples look like that. What are you doing? Well, yeah, this doesn't really look the same, but we can make it look the same. We know how to rearrange equations and stuff. So let's rearrange equations and stuff. That equation is admittedly Hideous. So let's distribute. I got a 10x. Get rid of that parentheses. So I got a minus y, and then the minus times the minus makes a plus 5, and then plus 16 equals 0. And if you look at this equation, you've got just a 10x, that's the only x term. You've got just a minus y, that's the only y term. These go together, plus 21 equals 0. And the last thing I'm going to do, just to make it look the same as all the above equations, is I'm going to subtract 21 on both sides, and then I'm looking at this. And I'm going to call that my new and improved equation 1. This is what all of these equations looked like, right? X term, y term equals a number. X term, y term equals a number. This is called standard form. That's supposed to be equation 1. Okay, this is called standard form, where you have the x term, y term equals a number. That's your standard form. And if you can get both of these weird-looking equations into standard form, you'll have an easier, well, that's really the way to do it. You can hurt yourself if you try it otherwise. Anyway, now I have to take this, come on you, I have to take this equation here and I have to massage the bottom one. So get rid of parentheses is what I like to do first. 20 minus 10y plus 40. Negative 2 times x is a minus 2x. Minus 2 times 1 is a minus 2. That equals 0. All of the terms are on the left side, so I'm going to combine them. Combine like terms, I should say. So looking at standard form again, looks like we'd like to put the x term first. So I'm just going to combine my x terms, and there's only one of them. So I've got the negative 2x first. Then I'll look for y terms, and there's only one of them. So negative 10y second. And then I'll combine all my constant terms together. So the constant terms are the numbers. So I have a plus 20 plus 40 makes a 60, and then minus 2 makes a positive 58. That's combining terms on the left side. The right side is still 0. Now, we're almost there. Just do the old subtract 58 on both sides trick to get our standard form. We have a negative 2x, we have a minus 10y, and on the other side we have a negative 58. And this becomes my new and improved equation 2. Cool. Now that we got that done, now we put these equations next to each other and we have a look at them. 10x minus y equals a negative 21. Negative 2x minus 10y equals a negative 58. Those are the two equations that we need to solve together. Got to take a spot check. Am I going to want to make my x terms go away? Be pretty easy to do. All I'd have to do is turn this negative 2x into a negative 10x, and then they would go away. I like that. It wouldn't be too hard to make these go away either. I could take the top and multiply it by, well, not just a 10, I'd have to multiply it by a negative 10, because if that's a negative 10y, I'd want a positive 10y. So, ooh, put your y back. What are you doing? Right, okay. I think I'll, again, make x's go away. I'm going to make the x's go away. So I'm going to take, let me use a different color again. I'm going to take this bottom equation, and I'm going to multiply it by 5. And this equation I'm going to use as is. So what do we got then? We've got 10x minus y equals negative 21, as is. 5 times this is a negative 10x. 5 times this is a negative 50y. 5 times this is a negative, I want to say 290. 250 plus 40, 290. Now I can add my equations together, and the x terms go away, because one's plus and one's minus. Plus 10x minus 10x, poof, they're gone. Minus y minus 50y, well, that's going to be a minus 51y. And then over here, oops, and then over here, a minus 21 with a minus 291, that's going to be a minus 311. So far, so good. Keep your eye on the y. It shows me that I need to shove a negative 51 under both sides. That way I'm canceling it off the y. Y equals, time for a calculator. Negative divided by negative is going to be positive. 311 divided by 51. Hit the SD button. Yeah, I'll go to 3 decimal places again. 6 point, looks like 0, 9, 8. 6.098. That's my y. Finish up by getting your x. Once more, I'm going to grab my top equation for no particular reason. And I'm going to say, okay, the top equation says 10x minus y. But wait, I know what y is. Y is 6.098. Okay. Equals a negative 21. Well, this won't take long to solve. Add this on both sides. I will have a 10x on the left, and on the right I'll have a negative something, right? The 21 is real big and it's negative, so we're going to have a negative something. Negative 21, add 6.098. We're getting a negative 14.902. Keep your eye on the x. It's got a 10 on it, which means shove a 10 underneath both sides. That has the basic effect of sliding your decimal back once. And if I keep it to 3 decimal places, it's going to be a negative 1.490. And I'm looking, I solved this problem before. I did get this for an answer. I did get this for an answer. It's all good. Okay, so it's a little bit of work, right? Look, it took me like that much. Took me that much to solve this problem. These are the kinds of equations, I should say, that don't those look kind of familiar? Those are the kinds of equations you get when you're doing the Kirchhoff voltage law and you're walking around in circles and you're plussing and minusing your voltage changes and then equaling 0 when you get to the end. This is where we're headed, is we're going to have equations like this that have both an x and a y in them, and we're going to need to solve for the x and the y. And this is how you do it. First, put them in standard form, rearrange the top equation, rearrange the bottom equation. When you've got them both in standard form, put them next to each other, and then it's like a standard homework problem. Make either the x's or the y's go away. You have to fudge the equations. Sometimes you have to fudge both of the equations. Make it so that either the x's or the y's will go away when you add, and soon you will have your solution. Whew, felt like I was going fast. It's a good thing you can pause, right? Good thing you can rewind. That was a good workout. Okay, cool. Let's stop.